We appreciate you listening to this presentation. So the topic of this project is going to be an open source neonatal syringe pump, and we'll just get right into it.
The problem statement. In low to middle income regions, the limited availability and the high costs associated with neonatal syringe pumps can hinder essential healthcare. Additionally, the repair and maintenance costs create a barrier to accessible healthcare for infants. So, we propose an open source device as a low cost alternative for neonatal infusion.
So for the scope, the main things we wanted to do was to construct mechanical and electrical components that can house and actuate the syringe. We wanted to have functional infusion parameters that we could change, such as the infusion volume, the infusion time. We wanted to include functionality that would allow the syringe to be primed before the infusion. And then we wanted to include any audio and visual alarms should there be issues with the syringe being installed incorrectly.
Project description. The syringe pump was designed using off the shelf electrical and mechanical components. The housing was 3D printed for interfacing motor to syringe. The Arduino Uno microcontroller board was used for software and input output.
The components used for the project was an Arduino as the main brain of the project, a stepper motor and driver for the syringe plunger, an LCD screen to display the menus and the flow rate, time, and volume, an LED and a buzzer for the alarms, the push buttons to control the Arduino, and the commands such as increment the volume and flow rate, limit switches for the correct installation of the syringe, and resistors for the LEDs.
So I'm just gonna do a quick overview of the functionality of the syringe pump we have here. So as you can see, these parts are 3D printed. They house the syringe that's there. This is a 3D printing stepper motor, which is interfacing into a stepper motor driver. And the main brain behind the board is this Arduino Uno. And so with the typical syringe pump, what you would want to be able to do first is to prime the system, so to remove all the air. So the menu we have here, we can switch to the prime menu, and then pushing the button here, it's a bit noisy, but it'll actuate the plunger that way, and that would push all the air out of the line. Additionally, there's a second menu here where you can adjust the different parameters of your infusion. So these buttons affect the time of infusion, these ones affect the volume of infusion. And then once you want to start the infusion, you would press the start button, and then it'll go through the whole protocol, uploading all the criteria on the screen here. Another little thing that we've included is a security alarm. So if for some reason the syringe gets removed prematurely, which would be dangerous, it'll abort the infusion and give a sound notification. Additionally, if you try to start an infusion without the syringe inserted, you'll get that same alarm notification. So that's just kind of some base functionality of this syringe pump, just for reference and for just a visual component. For the software design, it was mainly used on an Arduino IDE, which uses a C-style language with its own libraries and functions that we use some of. And kind of the backbone is a state machine architecture. So it would pass from the main menu state into the infusion state, and then there's a priming state as well. And within each of those states, we had our own custom programs and functions, which just allowed for a cleaner and easy to understand code and to easily add things in if that was necessary.
During this capstone project, we were able to learn and expand our understanding of different management techniques and skills, such as scope management, cost management, risk management, quality management, and schedule. We were able to do Gantt charts, bill of materials that we were never done before, and we were able to learn those skills for future jobs. We were also able to showcase our understanding of different skills necessary for the biomedical workforce, such as coding, electrical, and biomedical principles through the program, especially since the syringe pump is something that we would be constantly using at a hospital setting. This was able for us to understand how to do preventive maintenance and how a syringe pump actually works and how it is made for our future work.